Common denominator is going to be 1 plus secant times tangent.
Okay.
Fraction on the left needs a tangent, fraction on the right needs a 1 plus secant. Are we okay with that? FOIL it out. You're going to get tangent squared plus 1 plus 2 secant plus secant squared all over 1 plus secant tangent. Tangent squared is what?
Sine inverse.
Or secant squared minus 1. Putting that whole numerator in terms of secants. Mr. Brooks.
So when you have like a 1 plus secant squared, you always want to FOIL that out?
Yes, sir.
Couldn't you take that tan plus 1, isn't it the same as 1 plus tan, which is secant? And then you could secant squared, and then you could just have 2 secant and then 2 secant squared.
It works too. This is just going the other way. It's the same thing.
Alright.
Say, like I said, there are multiple ways of going about it. I saw the tangent squared right away, and I said, hey, that's secant squared minus 1, and I did that, but you're right. You could do the tangent squared plus 1 and done that too. It would have been quicker, actually. But same deal. Because now what I'm doing is eliminating the middle here, the minus 1 plus 1. So if I combine all my like terms, then you get the 2 secant squared and a 2 secant over the tangent 1 plus secant, which is leading you to the GCF, taking out a 2 secant. So secant is 1. Secant plus 1, 1 plus secant means the same thing. Those drop. Now rewrite it in terms of sines and cosines. Numerator, you get this. You get 2 over cosine divided by sine times cosine. As you bring that sine cosine up, you're going to flip it. Bless you. That's how you get your 2 cosine.
I didn't do that.
Bless you.
So, didn't it simplify? You can't leave it as 2 over sine.
No, because you can always go one step further. Okay. When you have a fractional one, you just write it as a reciprocal.
Question. Will we get this sheet out? No? I want to forget.
Next one. Mr. Brooks.
37.
37?
That's what I actually got.
Do. I thought we did this one in class.
I think we did.
Yeah, we did.
You kind of did.
You're going to kick yourself. Is that a perfect square? Is that a perfect square? Is that a subtraction sign? See where I'm going? Have you kicked yourself yet? Because cosine squared plus sine squared is?
That's the only one I got.
What else we got? What we got? Yeah, I do all the work too.
What number is it? 23. We did it.
Thanks.
Yeah. It was complicated.
Let's see. We did one like this yesterday. Go get your common denominator. Distribute through. Okay with that? I'm going to rewrite it. What am I going to do? Sign. Sir.
You get the two ones into that
Yeah.
top.
Yeah. You have to distribute, because you have to distribute the negative to the 1 minus sign as you got the common denominator. That's usually where people will mess up. God bless you. When you have a common denominator that you have 2 parts to, and you have to distribute a negative, that's usually where people tend to forget to distribute to the secondary term or the sign on that one. So that's how I got that. And then instead of rewriting it as negative sine squared plus sine, I wrote it as sine minus sine squared because it's the same.
Couldn't you have done that easier?
How many cards do you know?
What's that?
Is there like an easier way to do that, right?
Another way to do it?
Yeah, that's easier.
I thought I'd think of.
The one that you showed us in Flex, where you just did 1 minus sine, 1 plus sine over 1 minus sine.
I forgot about that. Yeah, or you do it this way. Thanks for reminding me.
Yeah.
Hey, watch this. It's even better.
Oh, are you trying on the other way?
Yeah. Is this a perfect square? Is that a perfect square? Is that a subtraction symbol? There's always an easier way sometimes. I forgot that I did it that way. Yes, ma'am.
39.
Do this. Oh, I didn't have the one. I was going to try to do like the old trick of I'm a magician. A math magician. She would have laughed. 39. Tangent plus cotangent over secant squared. So, rewrite the numerator in terms of sines and cosines, you get a common denominator. Since they're reciprocals of one another, when you have tangent and cotangent, one of the obvious things that you can do when you have to add them together is that it will create a Pythagorean identity of sine squared plus cosine squared. Right? It works. So you get sine squared plus cosine squared when you have the common denominator of cosine and sine. So to rewrite that then, I get 1 over cosine sine. Now I'm dividing that by secant. Excuse me. Which is 1 over cosine squared. Which I do what? Well, I take 1 over cosine sine, and I multiply it by this reciprocal. And you get cosine over sine, which is? No es bueno? Mr. Colton, what's up?
We do 33.
You got $1? No. Gas went up 5 cents.
5 cents?
I don't know. It was cheaper last week, now it's more expensive. I actually can't afford driving.
It's still pretty cheap.
It is really cheap. 33. Scottie Pippen. Cosine squared minus sine squared. You want to show it equals 1 minus 2 sine squared. Well, cosine squared is what in terms of sine?
1 minus sine.
Dang nabbit! Then combine like terms. Let's see.
That's the problem I'm gonna have. Remember, like, sine squared equals 1 minus cosine squared.
Change both sides of the equation.
No, work one side, work left, right. Okay. 51. Let's see. Well, this looks like fun. What are you gonna do first?
Boil it up.
Boil it. Boil it out. Cotangent. Did I put this one before? What? What's cotangent times tangent? One.
1.
The reciprocals of one another. So no matter what, I'm going to have 2 plus cotangent squared plus tangent squared. Okay with that? Okay. Oh, excuse me, I'm sorry. So we have 2 over 1 plus cosine. Well, actually, what's I'm gonna get to what? Cosecant, secant?
CSU.
So let's just, is it cotangent is cosecant squared minus 1, right? And tangent is secant squared minus 1. Almost there. And we've done that problem. To go from addition to multiplication with inverse or with reciprocal ones, what'd you have to do? Common denominator. You do the common denominator again. So you go with common denominator here, you get 1 over sine squared plus 1 over cosine squared, which gives you,
Wait, where'd you get,
what's that?
where'd you get those?
Why do I get these?
Yeah.
The reciprocal properties. A lot of times, whenever you have reciprocal properties that go from addition, and your solution needs to be reciprocal properties multiplication, you had to get a common denominator to add them together.
Well, couldn't you just, because there's 2, couldn't you just split the 2 and do 1 plus cotangent squared and 1 plus tangent squared, and then you get cosecant squared plus secant squared?
Yeah, that works too. That works too. But you still have to do this next step.
Oh, okay.
You still got to do the next step. But what you said is right. Yeah, that works. That works. So from here, you still got to go to the common denominator to get cosine squared plus sine squared over sine squared cosine squared. And that's how the numerator becomes 1. Denominator is cosine or sine squared. It's cosine squared, which you reciprocal it, and cosecant squared, secant squared. I reciprocaled them. Like the very last step? Yeah. That is reciprocal. 1 over cosine squared, 1 over sine squared is cosecant, secant squared. So, 1 over sine squared, cosine squared is cosecant squared, secant squared. What was it, Lucia? I'll get you next week. 49.
Alright.
I think this is up on the window too. I'm telling you, I did the tough ones and put them on the window for you. Make the left look like the right. There's two ways of doing this one. One way, you guys are going to kick yourself. The other way is the way you probably would think about doing it. Make the left look like the right. What I would do is, since I have to go to secants. Cosine is the reciprocal property of secant. You guys agree?
Yep.
So I'm going to write it as a complex fraction. 1 plus 1 over secant over 1 minus 1 over secant, which is going to force me to get common denominators on the top and on the bottom. So I'm going to get something over a secant here, multiply, I get a secant plus 1, and secant minus 1 over a secant. When I divide by that bottom fraction, I have to multiply by its, and see how the secants drop. There's your answer. Another way to do it, which I saw from a student in pre-calc, did this problem in pre-calc, was that knowing that you have to take the left to make it look like the right. This is really slick. Is it 1 minus cosine?
Yeah.
If I multiply that by some factor of 1, do I change it? Multiply the top and bottom by secant. What's 1 times secant? What's secant times cosine? Sorry, that's plus 1. What's 1 times secant? What's cosine times secant?
I guess that works.
Duh.
Never thought of it. I honestly never thought of that. Kid did it one step. I'm like, huh,
Extra credit.
very well. It works. It's legit.
Is that, can that be applied to other
Right.
problems?
Sometimes. It's a rarity. I don't think that comes up very often like that, but it works in this case. Caleb, what do you get? Good. What else we got? Yeah, 47. A foiling we will go, a foiling we will go, hi ho the dairy-o, a foiling you will go. Oh, forgot to sign. Two cosine sine drops. What's cosine plus sine? What's cosine plus sine?
1.
She's like, I got 2.
2.
I don't know if that's right.
Error 5. Which do error 2? It's a thing. Hi, how are you? You just waving because you want 5 2 here, right?
You said that like there's many different ways.
The answer is 2.
Oh yeah.
Yep.
That's
Plus
dumb.
one is
What did you do?
Cosine squared, cosine squared, like add them together, cosine squared plus cosine squared.
Good answer.
Subtract out the two and cosine squared.
Works,
Should be like some sign.
didn't it?
Secant.
Sometimes it's just an easier way to get there. That's all. Mr. Olson, I'll get you next one.
All right.
Be-dee-dee-dee-dee-dee-dee.
shape by. That's all I
What are we doing here?
41.
Good.
So this is cosine over sine times cosine times sine over cosine plus sine. You okay with that? Inside the parentheses, I see right away that happens. Which gives me sine plus sine, which is?
2 sine.
So cosine over sine times 2 sine is
One of them.
2 cosine.
Okay, hold up.
Oh.
It works, yeah. It does the same. It'll go the same way. But I saw sines and cosines and tangents and cotangents. I just flip them right away and just go. Sir.
43.
It seems like everything's easy when you put it into sine and cosine. So,
It's kind of the trick.
what do you recommend?
But
If you can, yeah.
Okay.
So on the left, I can rewrite tangent squared as secant squared minus 1. Very good.
I don't know when to turn into secant squared minus 1 or like sine squared over cosine.
Well, a lot when you see tangent squared and you see another secant, think Pythagorean identity. Okay. Because now we can do that shortcut is secant squared a perfect square
Yeah.
is 1 a perfect square.
Yes.
Is that a subtraction symbol?
Yes.
So you can do that quick shortcut now. Otherwise, if you went out and got common denominator, you're still going to get the exact same thing. So bless you. You'll get the exact same thing. Okay. Yes, ma'am. You have not answered. You haven't asked in the form of a question.
I know, I'm just trying to.
I'm messing with you.
They placed twice?
So, for, the sine squared, you do the cosine squared, tangent squared. Okay, for all the like Pythagorean identities.
Yeah.
You can,
I'll figure it out.
you can like, do the different squares except for secant.
Except for secant and cosecant, because secant and cosecant one, you get, what is it, tangent squared would be secant squared minus 1. So you can do the difference out by moving the 1 over.
Yeah, no, yeah, if you were, if you get secant squared.
Oh, yeah, that will work, yeah. Because it'd be 1 plus
But
tangent
it'll
squared.
work for like the other ones that are.
The manipulating ones, yeah. If you can get into the difference of squares, yeah. What else we got, guys? Got a little bit of time here. I got a couple more for you, but. Which one?
What is it I just figured out? Really, almost,
But I kicked myself.
it's almost like
We did that one.
50 to the
It's the same thing as 36.
Okay.
Get common denominators and multiply through. It's
the same as
real fast. Yeah.
It's kind of the same as 51 too, like the last part.
To be honest with you, some of the ones that you did on here are a lot harder than you're ever going to see. I'm not going to lie to you. The ones that are on here are a lot more difficult than need be. That's why we like giving them to you, to make you annoyed and make you afraid and scared. Afraid. So I have another one of these. I mean, we've done so many of these now. And I'm not saying that you have to do all 47 of these or whatever.
It's supposed to be
They're all
equal
supposed to be, you got
CSC and
like keep waiting for you.
I think I've done enough of them. So I don't know. When I'm looking at this one, this one, most of these are kind of are I can't say that I don't think they are more than 3 steps, 4 max really, with a lot of these. All right, I would just randomly just pick some and start working. Now, one of the things we did not do is we did not do something with square roots. I'm not putting one of them on there tomorrow, but maybe on a test you might see a square root one.
What number?
It's on the back. So one of the things you do here is I want you to think of this as order of operation problem. When you have an order of operations, you have to work on the inside of the parentheses first and work your way out. Do you agree? Yeah. That's what you're looking at. You try to simplify the interior prior to taking the square root. So if you have secant plus tangent, secant minus tangent, what I would do is automatically write it in terms of sines and cosines. 1 over cosine plus sine over cosine all over 1 over cosine minus sine over cosine. See how you're gonna get, how you get a common denominator right away?
Yeah.
Okay. In doing that, you wind up with 1 plus sine over cosine divided by 1 minus sine over cosine. Excuse me.
You do that. You do 1 plus sine. Multiply.
Now you get 1 plus sine over cosine. And then times cosine over 1 minus sine. So you get 1 plus sine over 1 minus sine. Now what do you do?
Well.
Think about what you have to accomplish here. At this point, you want to get rid of that and take a square root. So you're on the right track here. How do you get rid of a 1 minus sign in the denominator?
Oh, you had to.
Simple.
1 plus sign. Remember that? Multiply by conjugate? Because look what happens then. If you do a conjugate, you have a 1 plus sign 1 minus sign. Here you get the quantity 1 plus sine squared. Here you get 1 minus sine squared. What's 1 minus sine squared?
That's sense.
Now, what happens with that fraction, the exponent? It drops itself out. And you get the 1 plus sine over cosine. We have not done one like that. Won't see one tomorrow, but maybe next week we will. I told you I had 2 simplify, 2 verify questions for you.
Tomorrow?
Tomorrow.
When I flip this?
Just 4. 2 simplify, 2 verify, because we have what, 28 minutes? It's plenty of time. Some of the ones you guys were doing yesterday, I'm not gonna lie, are more complicated than what you have for tomorrow. It should not be more than 3 steps, 4 max.
What, tomorrow or?
Yeah.
Will we get this tomorrow?
No.
I asked it once.
You only need to, you know everything on there except probably the tangent squared plus 1 and cotangent squared plus 1.
Yep.
Those are probably the only 2 that you don't know. The rest of them, you know your reciprocal properties, you know that tangent's sine over cosine, you know that sine squared plus cosine squared is 1.
I just need to memorize the bottom 3.
You don't even know the bottom, you have to know the bottom, you only need to know 2 out of those bottom, because you probably already know sine squared plus cosine squared.
Yeah, I know that.
Then you only need to know 2. It's the same idea. Did I say that you guys had to memorize that unit circle? No, you just had to know what angle came first. 30. Once you knew that, everything fell into place. Okay? It's the same basic idea. You know all the properties. You just don't know, or you don't remember 2 out of the 3 Pythagoreans. Tangent squared plus 1 is secant squared. And then cotangent squared plus 1 is cosecant squared. Like I said, on these, I don't know, like just pick and choose and try to go through. If you see one that you, I give you all ones that were verifying. You have to do the same stuff and simplify. You just don't know what your ending is. That's the only difference. Just go from there. Okay. Trust yourselves.
That's not smart.